fractions seminar or webinar on fractions. And I'm going to share my PowerPoint presentation with you this evening. I thought I was sharing my PowerPoint. Maybe I'm sharing my screen. Let me know when you can see my PowerPoint presentation. You're the only one that can tell me. Okay, good. Well, fractions. Okay, so if you are confused a little bit by fractions, if they kind of trip you up when you go to add or subtract or multiply or divide and you really just can't remember the rules, you're not alone. Many students, and Deborah and I have been teaching this for many years, and this is a concept, and this is the reason why we do a webinar on fractions. It's a concept that if you don't have it straight in your understanding and in your skill set, it can seem a little tricky and trip you up at times. So hopefully by the end of this webinar, you'll have a little bit better understanding and a more solid grasp on operation with fractions. First of all, let's talk about what really is a fraction. You know, all of us probably know fractions, and they're parts of something that is a whole. So if we have a whole unit, you know, let's just say, for example, this circle, that represents a whole unit, 1 unit. Well, anything less than 1 whole unit would be a fractional part. Furthermore, that whole unit must be divided into equal parts. So, for example, in this circle, the whole circle, one circle is divided into 3 equal parts. So a fraction is any part of something that is whole. A part is expressed in the numerator of the fraction, and how many parts make up the whole is expressed in the denominator of that fraction. So, for example, in this circle, we've got 1 shaded part of this 1 whole circle that's divided into 3 parts. So the circle is divided in 3 equal parts, and 1 of the parts is shaded. So that's where we get the 1/3, okay? 1/3 of the circle is shaded. Let's look at the second circle because it's also divided up, but it's divided up into more pieces, although the circles are identical, so it represents the same amount of 1 whole, only it's broken up into more pieces, which means that each piece is smaller. Okay, so this circle happens to be divided up into 6 equal parts, and 2 of those parts are shaded. You'll notice the 1/3, this part of the circle in the top one, that part, is an equal amount as the shaded part in the second circle, 2 out of 6 parts that are shaded. It's an equal amount, but expressed in different ways based on how many parts the whole has been divided up into. So if we say these are equal amounts of the circle shaded, then I can say that 1/3 is the same as 2/6 as long as the whole is the same, as long as we're talking about the same size of 1 whole. Okay, so 1/3 is equal to 2/6. It's the same amount, it's just expressed in 2 different ways. When we talk about equivalent fractions, this is exactly what we mean. We mean, hey, we're talking about the same amount of this circle that's shaded, only we're expressing it in a couple different ways. One circle is divided into less parts. This is 1, 2, 3. And then another circle is divided up into more but smaller parts. And these 2 amounts, though they're written differently, are the same. We're going to look at how you simplify fractions, okay? Because in this class and in algebra as a whole, we want your answer always to be in its simplest form. So let's understand why 1/3 and 2/6 is the same. If I were to break down 2/6 into its factors, which you learned about factors during Module 1, 2 times 1, and then 6 is the same as 2 times 3, you can see that in this, which we broke down into factors, we have a 2 over 2. Any number over itself is just 1. So when you simplify fractions, it's kind of what I call pulling out the ones in your fraction. we're going to pull out the ones, and that leaves us with fraction in simplest form. So let's look at a few examples here in how to simplify fractions. Now, 8/12 is our first fraction, and we want to simplify that fraction by looking for a factor of value in the numerator, 8, and a factor of the value in the denominator, which is 12, that may be the same. So let's think about the factors of 8. I know that 4 times 2 will give me 8. What about the factors of 12? Well, I know that 4 is also a factor of 12 because 4 times 3 will give me 12. You see, we've got a 4 over 4. We break down 8 and 12. They share a factor of 4. So 4 over 4 just becomes 1. So that leaves 2 thirds. So to simplify 8/12, we find the greatest common factor, which you learned about in week 1, the greatest, not the greatest factor, but the greatest common factor, the greatest factor that they have in common, so that we can simplify the fraction and express it in the simplest form possible. Now look at 36 over 81, and I know that 9 is a factor of both 36 because 36 divided by 9 is 4. 81 divided by 9 is 9. So I can pull out a 9 over 9 or divide out both in the numerator and denominator, and I'm left with 4/9. For 21 over 24, I know that 7 times 3 is 21, and 8 times 3 is 4. So they share a factor of 3. So these 3's, 3 over 3, we can, you want to call it divide out, cancel out, pull out, whatever you want to call it. That simplifies to 7/8. How you simplify fractions by finding the greatest common factor of your numerator and denominator, factoring that out or dividing that out. Either way you want to look at it, it's the same result, whether you want to down your numerator and denominator into those factors and then pull out the 1 or cancel out the 1. That's how you simplify fractions. And again, you always want to express your fractions, your final answer, in simplest form. Now look at these types of fractions. How do we simplify, let's just say 12 over 1 or any number over 1? And sometimes we just expressed as an answer, and you will notice if you express your answer in this form, MyLabs Plus will count you wrong. Well, that's because this may be the correct value, but it's not expressed in simplest form. Any number over 1 is a whole number. Okay? So if you end up as a result of 12 over 1 or 5 over 1 or negative 6 over 1, you want to simplify that to be a whole value. Okay, so any number over 1 is just itself as a whole number. Now, what happens if you have a 0 in the numerator? 0 divided by any number is just 0. And again, 0, you have 0 items and you want to put nothing into 3 groups. You can do that because each group will have 0 items in there because you didn't have anything to begin with. So if you have 0 number of apples and you want to put 0 apples into 3 groups, each group will have 0. Now, let's look at when 0 is in the denominator. This is a value that really can't be defined. And because if you have 4 apples, you can't divide up 4 apples into 0 groups. It doesn't make sense. You're still going to have at least one group because you have 4 apples. So dividing any number by 0 doesn't make sense. It's what's called an undefined value. Okay, so remember, when 0 is in the numerator, that's a real value, and that value is 0. When 0 is in the denominator, that is a value that doesn't make any sense at all, and we call that an undefined value. Okay, it will make sense a little later when we get to linear equations and slopes of lines. That it will have an application we get there. Okay, operations with fractions. First, we get to multiplying fractions. And this is probably the most straightforward operation with fractions that you can do, simply because you don't need a common denominator. It doesn't matter what numbers are make up your fractions. You simply multiply across the numerator and multiply across the denominator. This is a simple operation with fractions as you can get. So when you multiply fractions, simply multiply across the numerator, multiply across the denominator, and have your answer. 4 times 2 is 8. 3 times 7 is 21. There's no common factor between 8 and 21, so that will be your final answer. What happens when we multiply a fraction times a whole number? Now again, when you multiply fractions, you have to multiply across the numerator and across the denominator. So we need to make this whole number become a fraction. And remember, any whole number can become a fraction by just placing that whole number over 1. It's the same thing, same value. Now we simply multiply across the numerator and across the denominator. So 3 times 2 in the numerator and 5 times 1 in the denominator. When you multiply those across, you should get 6. Don't feel the need when you end up with an improper fraction as a solution. There's no need in changing that into a mixed number. In fact, in algebra, we prefer to have it your answer left as an improper fraction. So you won't want to change this into 1 1/5. You'll want to leave it as 6/5. An improper fraction is just fine when you're working in algebra. So no need to change that to a mixed number. Look at a couple others, because oftentimes when you multiply, you need to simplify your answer. So again, let's look at this a couple different ways. Okay, again, we can multiply straight across the numerator and straight across the denominator, which makes 11 times 5 in the numerator, 18 times 6 in the denominator. Multiplying across, we get 55 in the numerator. And multiplying across the denominator, we get 90. 50 times 6 is 90. This is not expressed in simplest form because 5 is a factor of both the numerator and the denominator. So when we simplify this, we get 11/18. Now let's look way back here when we express this as multiplying the numerator and denominator. I wouldn't have to go ahead and multiply these together and get larger numbers than what I wanted, because I can see that there's already a common factor in the numerator and in the denominator, and that common factor is 5. So I could go ahead and divide out of 5, because 5 divided by 5 is 1, and 5 into 15 leaves 3. So at this point, I could start looking for my common factors and divide them out before I multiply across the numerator and denominator. If I did it this way, I would bypass this step here and go immediately to my simplified answer, because 11 times 1 is 11, and 3 times 6 will give me 18. So either way you want to do it, if you just want to go ahead and multiply it out and then look for common factors to simplify your answer, that's perfectly fine. If at this point, when you multiply the numerator, 11 times 5, and then multiply the denominator, 15 times 6, if you want to go ahead and pull out common factors at this step, then you won't be worried about large numbers looking for larger factors share in common. Okay, let's look at another example. 6/18 times 15/16, or 15/16. If you have a chance, when you're given a problem like this, to simplify one of these fractions, go ahead and do it so that you're not multiplying larger numbers. For example, I know that 6/18 is not simplified because 6 is a factor of 6, and it's also a factor of 18. So I can rewrite this first fraction as the simplified 1/3. 6 goes into 6 once and into 18 times. So 6/18 simplifies to be 1/3. and then can multiply it by 15/16 and multiply across the numerator. 15 times 1 is 15. And then we will multiply across the denominator. 3 times 16, or, there's another common factor there, but anyway, is 48. Okay, there's another common factor here of 3. 3 will go into 15 5 times, and to 48 6 times. So my final answer is 5/16. So you see there's a number of different ways that we can do this. We can go ahead and multiply completely across and then simplify. We can pull out what common factors we see and simplify further, or we can simplify altogether at this step. At this step, I could have further simplified because I know that 3 and 15 share a common factor of 3. So that would be 1, and that would be 5. That would skip this middle step and take me all the way to the final answer. There's many different ways that you can multiply and simplify your answers. So choose which way you understand the best and just stick with that. Talk about dividing fractions, because that's very, very similar to what you just saw, except that we have to fetch the second fraction. Multiplication and division are inverse operations, and what I mean when I say that is if I were to multiply, let's just say multiply 5 times 2, turn around and divide by 2, it undoes each other, so I end up where I started. Okay, so multiplication and division kind of undo each other because they're inverse operations. So that is the reason why you change division of fractions into multiplication. Let me see if I can explain this. If I want to take divide 10 by 2. By 2, that's the same thing as saying 10 times 1/2. They'll give me 5. So you see that I changed division to multiplication by the inverse, okay? Because division and multiplication are inverse operations, so we can change division to be multiplying by the inverse, or the flip of that second value. So let's look at our first example, 1/3 divided by 1/2. So we can change division into multiplication. I'll just try to use a dot if it will stay there. Sometimes my pen wants to erase it. Multiply the inverse of 1/2, which is 2 over 1. Notice I changed division to multiplication and then changed the second fraction, or what I'm dividing by, flip it and multiply by the inverse of that fraction. That gives me now multiply across the numerator and across the denominator. So 1/3 divided by 1/2 is the same as 1/3 times 2 over 1, which gives me 2/3. Example, 4/7 divide 3. 3 is a whole number. Remember, when we're doing operations with fractions, we need to change any whole number to become a fraction. So let's change 4/7 divided by 3 to be 4/7 divided by 3 over 1. So we're going to have to change division into multiplying by the inverse of 3 over 1, which is 1 over 3. Multiply across the numerator, 4 times 1 is 4, and across the denominator, 7 times 3 is 21. 21. So 4/7 divided by 3 is 4 over 21. Let's look at this last example, 7/2 divided by 28/3. We're going to change division to multiplication by the inverse, or the reciprocal of that fraction, the second fraction. And at this point, we can multiply across the numerator and across the denominator. Let me just express that so that you can see how that works. Again, as we saw in the last slide, A common factor in the numerator and denominator, so I'm going to choose to simplify at this stage. 7's a factor of 7. It goes into 7 once and into 28 4 times. So I've got 1 times 3, or 3, in the numerator, and 2 times 4, or 8, in the denominator. You could also just go ahead and multiply 21 over 56 and then plus 7 and simplify the fraction that way. Either way you want to do it. All right, that's multiplying and dividing fractions. Let's look at adding and subtracting, because it is different than the straightforwardness of multiplying and dividing. And that's because when you add and when you combine, in next week or so, you're going to look at combining terms, not just values or numbers or fractions, but you're going to be combining variables and different terms. So when you go to add or subtract fractions or other term, they have to be alike. Okay? So, for example, 1/2 plus 1/3. You have to combine terms, add or subtract terms that are alike. Here we have 1, something that's divided into 2 equal parts, and we're going to add 1 part of something that's divided into 3 equal parts. So we're not adding things that are alike. So what we need to do is find out how we can change these fractions so that they will be alike. So I've got a rectangle represented here, and this big rectangle is divided into 2 equal parts. So this is my 1/2. This is my 1/2. But I want to add the same rectangle, but now it's divided up into 3 equal parts. I want to add a third 1/2. I need to divide that rectangle up into something that is the same. It can be a half or into thirds, and that's usually you find the least common multiple of your denominators. But the next higher up number that both of these denominators will divide evenly into. That seems to be 6. Between 2 and 3, 2 is a factor of 6, and so is 3. That's the least common multiple between 2 and 6. So what we want to do is change these fractions both to have a denominator of 6, so we'll be adding things that are alike. So 1/2 is how many sixths? So what do we do to change 2 to 6? We multiply 2 times 3. So we have to do that same thing in the numerator. So 1/2 is the same as, and you can see it illustrated down here, as 1, 2, 3 sixths. So the yellow part of this box down here is divided into 6 equal parts, and the yellow part makes up 3 out of those 6. So we can change 1/2 to be the same as 3 sixths. About 1/3. How many sixths is the same as saying 1/3? Well, what do we do to 3 to change them into 6? We multiply him by 2. So due to the denominator, we have to do in the numerator. So we saw this in the first slide. 1/3 is the same as 2 sixths. And we can see that illustrated right here. The pink is shaded 2 sixths of that. So now we have things that are alike, where we've got 3 sixths and we want to add 2 more sixths to it. So that makes 1, 2, 3, 4, 5, or 3 plus 2 is 5 sixths. So we have to add things that are alike. If they're not alike, we have to change them, change the form to an equivalent fraction to have the same or a common denominator for both fractions. So we're adding the same thing. 3 sixths, 2 more sixths, is 5 sixths altogether. Now let's if we can do that without demonstrations. We're looking for a common denominator here. All right, we've got 1/2 plus 3/8. Clearly, we don't have the same denominator. We need to find the least common multiple between these two denominators. And it looks like 8, because 2 is also a factor of 8. 8 goes into 8 once. So it looks like we only need to change this first fraction to be a certain number of 8ths. So how do we change 1/2 to be a certain number of 8ths? Well, 2 times 4 will give me 8. And so multiply the denominator by 4. I also have to multiply the numerator by 4 to give me the new fraction 4/8. So 1/2 is the same as 4/8. Now we have a common denominator. We have 4/8, and we want to add 3 more 8s. Think about that rectangle divided up into 8 equal parts. You've got 4 shaded, and then 3 more. What part of that box is shaded is 4 plus 3, or 7/8. One that might not be so very obvious, and that is 7/15 plus 5/12. And we're concerned with having the same denominator. So we might need to think a little bit more about this. And if you can't, off the top of your head, think about what a common denominator between these two numbers might be, it might be a good idea for you just to list the multiples of each number. And by that, we learned in week 1, multiples are the what you get when you multiply the given value by 1 and by 2 and by 3, by 3, and 4, and so on. Same thing with your second value when you multiply 12 by 1 and 12 by 2, 12 by 3, 4, and 2 by 5, until you find one that they have in common. Then you can change your fraction to have the same denominator, 60 in the denominator, because that's the least common multiple of your denominators. So 15 times what will give me 60? Well, it look like 4, 1, 2, 3, 4. So I've got to multiply my numerator also by 4. So 7/15 is the same as 28/60. How did I make 12 become 60? I multiplied by 5. So I have to multiply my numerator by 5 also to change that fraction to have a denominator of 60. Now we're talking about the same thing. We've got 28/60ths, and want to add 25 more 60ths. So that becomes 53 60ths. So that's as small as it can get. There's no common factor between 53 and 60. Adding fractions, you have to add things that are alike. Therefore, your denominators have to be the same. Same thing with subtracting fractions. If you're going to take away a portion of a given value, you have to be talking about the same thing. Here we've got 5/9, and we want to take away or subtract 2 of those 9. Same thing, same denominator, so we can simply subtract in numerator. That's leave me with 3/9. But 3/9 I can simplify because 3 is a factor of both 3 and 9. So final answer would be 1/3. Let's do a couple more of finding common denominators. 19/28, and I'm going to subtract 3/7. Okay. Well, I know 7 is a factor of 28, so I don't need to change this first fraction. I need to change 3/7 to have a denominator of 28. Now, 7 times 4 gives me 28, so I need to multiply the numerator by 4 also, and that will give me 12/28. So 19/28 minus 12/28. All right, we're looking at like terms, things that are alike, same denominator. We subtract just the numerators. 19 minus 12 gives me 7/28, and I can simplify that to 1/4 since 7 is a factor of both 7 and 28. As subtracting fractions, you have to have a common denominator. Remember, back to multiplying and dividing, you do not need a common denominator to multiply or divide. All right, let's look at one last example, 5/8 minus 20ths. Well, they don't have a common denominator, nor is 8. I can't multiply 8 by any whole number to give me 20. So I'm going to have to change both of these fractions to have a common denominator. What's the least common multiple between 8 and 20? We know that 20 and 8, I can multiply 8 times 5 to give me 40, and 20 times 2 will give me 40. So I believe that 40 is going to be the least common multiple between 8 and 20. So again, multiplied 8 times 5 to give me 40. So I need to multiply the numerator by 5 to get 25 over 40. And 20 times 2 will give me 40 in the second fraction, so I need to multiply the numerator by 2. 11 times 2 is 22. So now I have a common denominator. By the way, this is a good way, if you're not adding or subtracting fractions, this is a good way just to compare fractions. If I had not produced a common denominator and changed these fractions, which one would you have thought would be the bigger portion? Would it be 5/8 or 11/20? This is a good way to figure out which is larger, which fraction is larger. By changing them to have a common denominator, we clearly see that 5/8 is larger because we've got 25/40 compared to 22/40. That's just a little extra. You won't have to do that in this session, but I just thought anybody was interested. So 25 minus 22 will give 3 over 40. Answer, since there's no common factors in that. Now, let's look at one last thing. How do we do all of them at the same time? Operations. I'm sure this is familiar to many of you. Order of operations, this acronym PEMDAS, and that just tells you what order to perform operations when you've got a string of terms that you're trying to have, and there's different operations between them. The basic order of those means you look inside and see what is in parentheses. Spell it correctly. Parentheses first. You do any operations inside parentheses first. And then outside, once you do that, you look for exponents and evaluate any exponents in your expression. And then you will multiply and or divide, whichever comes first, from left to right. As you're reading through your expression, you do these operations from left to right. So if you get to division first, you would divide those numbers first. If you get multiplication first when you're reading the expression from left to right, then you multiply first. And after you're done with multiplication and division, you will add and subtract again from to right, which comes first. Left, right, adding through your expression. This will be on the screen if you watch the recording. So I'm going to do one last example, and then we'll be done for the night. Here we have 3/5 times 1/4 plus 9/21, 21st, or 9 or 21 divided by 20 over 21. So what do we do first? Well, we don't have any parentheses, so we can mark that off. We don't have any exponents to evaluate. We can mark that off. So we need to look for multiplication and division, whichever comes first, as we're reading this expression from left to right. As we're reading this, I see I get to multiplying first and multiplying these first two fractions. Remember, when you multiply, you just simply multiply straight across the numerator, straight across denominator. You do not need a common denominator. So 3 times 1 will give me 3, and 5 times 4 will give me 20. Everybody else just comes down. So you're working through the problem, just rewrite the rest of the problem as you see it. What do we do? Do we add these two? Well, because I see that there's division, I'm not done with multiplication or division. I can't add it until we're done with every multiplication and division. So it looks like I need to divide these last two fractions before I'm going to add. That means that 3 over 20 just has to come down as is. And the sign. And now to divide these fractions, remember, I need to change division to multiplication. I'm going to multiply by the inverse, so I need to flip the second fraction. I'm still doing division or multiplication. That's a multiplication now. It's not division. So I see that there is the same thing in the denominator and the numerator, 21 over 21. So I can simplify before I multiply. Okay? So that's give me 3/20 plus 9 times 1 in the numerator, or 9, and 1 times 20, or 20 in the denominator. We're done with multiplication and division, and look, we're just left with addition, and this problem was so nice to us. It left us with adding fractions that already have the same denominator. So we've got 3/20, we're going to add 9/20, it's going to give me 12/20, but I know that 4 is a factor of both 12, goes into 12 3 times, and 4 goes into 20 5 times. So when I simplify 12/20, I get 3/5 for my final answer. The order of operations, remember, parentheses, exponents, multiplication and division, left to right, do all of them before you move on to addition and subtraction. I hope this evening has been helpful to you. Again, you'll be receiving a link to the recording for it. We've got 3 more webinars. Next month, we'll be talking about how to solve equations with just a single variable. I think toward the end, we'll have multiple variables too. March 21st, we'll be talking about graphing and writing linear equations in Module 9. And way down the road, which it'll come by all too soon, we'll have another webinar on factoring. Thank you all so much for your attendance. I'm going to stop sharing my screen, and I will stop recording if I can find how to do that. And I bid you a good evening. Thank you so much, Deborah. I appreciate it.
Bye.